Hi friend. Data in databases is typically stored in different tables. For example, you might have one table where you have your employees and another table where you have departments. Now, if you want to find out which employee is working in which department, you need to somehow bring them together. And this is exactly what the join functionality in SQL is doing. The tricky part is that there are many different join types in SQL, and they all serve a slightly different purpose. In this video, we will go through them one by one, explaining what they are, how they work, and when you need them. In the end, we will even arrive at complex many-to-many joins over multiple tables, but don't worry, we will get there slowly, one by one, starting with the simples and building our knowledge from there. So now let's do exactly that. We want to join our employees and our departments to get a list of employees and the department that they are working in. First of all, let's have a look at our data that we are working with. We have an employee table with 5 rows. We have a column employee ID, department ID, first name, last name, salary, and the manager. And then we have a second table, the department table. This one just has 2 columns and 3 rows. We have the department ID and the department. And as we saw, we have the department ID in both tables. So we have it here in the department table, and looking again in the employee table, we have it as a second column here. And this already indicates that this can be our join condition. Whenever we want to join 2 tables, we need to specify a column on which we want to do that. So in this case, it should be the department ID. Let's say we want to select from our employee table, and then we will say we make an inner join. This is the first join type that we learn now, to the department table, and after the on we specify the columns that we want to join them on. If I try to do now department ID equals to department ID, this will not work. I already see the squiggly line here, and I try to run it, and I get the information that we have an ambiguous column named department ID. Why is that? Whenever we join, we need to specify the columns and where they come from. In this case, we have the department ID in both tables, so it's not clear which one is which one. So we need to specify employee ID dot department ID equals to department dot department ID. Now SQL knows, okay, the department ID from the employee table shall be joined to the department ID column of the department table. Now when we run this, we have already our result set. This works, but it looks rather cluttered. A very long join clause here, and we can make it shorter. To do that, we can use aliases. We just put in name under here. Typically you would have it very short. In this case, I will call our employee table E, and the department table shall be D. And then I can say I use this alias here and replace the employee, and I take the D and replace the department table. It will work exactly the same, but it's just more concise to write it like this. As you see, the result is the same. Now with this alias, I can also specify if I just want some columns from one or the other table. So for example, from the E table, the employee table, I can say give me just the first name, and maybe I want the last name. And then I can say from the D table that is now joined, I want the department. Running this, we see, okay, Ben Smith is working in IT, John Miller in IT, Ed Jones works in HR, as well as Ben Holmes also. If I look now back into our base table, the employee table, I see that we have 5 employees, numbered 1 to 5. And they have a department ID, and it's null for Norman. And if I look at the result of our join again, we see that Norman Brown is lost. Why is it? Whenever you do an inner join, you will only get the results that are present in both tables. Shown as a Venn diagram, an inner join just returns the intersecting area between two tables when we join those together. Everything that is not present in the other one will not be present in the final result set. That's exactly what happened here. So when we make an inner join from the employee table to the department on the join clause department ID equals to department ID, the SQL engine is searching the rows which have the same ID on both sides and matches them together. And here we can see Norman does not have an equivalent on the department side, so he will be just removed. This may or may not be the desired outcome. Let's say we want to keep all employees, but we want to join the department ID as well. What do we do then? This is where the left join comes in handy. When we look at the Venn diagram for a left join, you will see that now the left table is completely filled out and the intersecting area, but just not the right side. So let's have a look at the code how this works out. Switching an inner join to a left join is as easy as replacing the inner with the left. In this point, so we replace the inner join with the left join. If we look at the result now, down here you see before we had 4 rows, now with the left join we have 5 rows, and Norman is here and the department is null. That's what the left join is doing. Give me everything from the left side. So when you look at this as a separator, you have the left side and the right side from the join. From the left side, the left join takes all and matches, if available, from the right side. If not available, we still, according to the Venn diagram, take everything from the left side. As you might have guessed, if there's a left join, there should probably also be a right join, and that's definitely the case. Let's have a look at the Venn diagram. Here you see that now we get every row from the right side, but not from the left side. So let's see it in the code. Again, switching from left to right is as easy as switching here in the right join. Now before here we had the left join result. If I run this, we have the right join result. No more Norman, but suddenly we have a finance department here. What's happening here? Let's look at our base table. The employee table, we have the department IDs 1 and 2 and not available. And in department, we have 1, 2 and number 3, the finance department. So we have defined a finance department, but nobody's working there. And this is exactly what we get when we run this right join. We have now taken everything from the right side, so from the department side, and there is the finance, and then we, from the finance, from the number 3, ID number 3, we look on the employee side and there's nothing. So we keep this row, but we leave it null here from the employee side. For us humans, it's much more natural to comprehend what happens on the left join than on the right join. You might have just realized the same, that why am I looking first on the right side and then back on the left side with the right join? And this is why in practice I have never seen a right join really used in practice, and you can always switch them around. So let's look at the Venn diagram. I have my right join, and when I flip it around, it looks like a left join. And this is exactly what happens if I switch the sides. So I can just switch the tables and switch right for left, and I get the same result. If I say the department is on the left side of my join, and I will move the employee to the right side and make it a left instead of a right join, the result should stay the same. And fair enough, it does. Now I take everything from the department, and on the left side I join from the employee table if available. It looks now this is on the right side and this is on the left side, but this is just depending on the order of columns that I have defined up here. I can just switch this one around also, and we will see that it looks like a normal left join. We have everything from the left side, and then we join from the right side whenever available. So recommendation is understand what a right join is, but never use it in practice. Always replace it with a left join. It's much easier to read. Now we realize that on one case we lost the finance, and in the other case we lost Norman from the employees. What do we do if we want both? Let's have a look at the full join. In this case, we see now the Venn diagram is fully filled. It's a full join. We join everything from both sides, regardless whether there are matching rows on the other side. And again, syntax-wise, quite easy once you have grasped the other joins. It's just about replacing the left with a full, in this case, and we run it. And now we are at 6 rows. From the department, we have the finance, which has no equivalent from the employees, and vice versa. From the employees, we have Norman Brown, who is working in an unknown department. And with this, you already know the basics of the SQL joins. Everything that follows now builds upon these basics, but in general, it always works the same. It's just special types of applications of the joins that we will look at now. First, let's start with a self-join. A self-join is a self-referencing join, which joins the table again with itself. Let's have a look in the code how this works out. First of all, let's get rid of the department. We will now only work with the employees. Let's have a look at the data. We have an employee ID and a manager. So we see that our employee number 1 is Ben Smith. Employee number 2 is John Miller. And in the manager ID column, we see which employee is their manager. So this reads like the manager of John Miller is the employee with ID 1, which is in the same table Ben Smith. And the same holds true for all the other 4. All the time it's Ben Smith who is the manager. So let's have a look at how we can query this. We want to see our employee, and then we will inner join, a join that we already know. But now comes the interesting part. We will join the employee table again. Syntax-wise, it's just the same, just that we are joining now the same table again. And I give it now an M as the alias for me to indicate that now this is my manager. How do we join them? We join them from the M. We want to have the employee ID from the manager. And that one shall be equal to, from the employee, the manager ID. And now that you see this, we have referencing 2 different columns here. We reference the employee ID joined to the manager. And now I can say I want the first name and the last name of my employee, and from my manager, the M, I will do the same. First name and last name. And maybe I also want to give them an alias here so it's easier to read, which with the self-join most of the time makes sense. So this is our first name. Here we have our last name, but now comes a different part, and this is the first name of manager, and this one is last name of manager. In practice I would probably choose shorter names, but this makes it a little bit easier to understand. Let's run this, and there we have it. We have our John Miller, and whose boss is John Miller? It's Ben Smith. And yeah, as seen before, Ben Smith is the manager of all 4, so here they are. What we see now is Ben Smith itself is not shown here as an employee anymore. Why is it? Think about it. Maybe pause the video and see if you can come up with the solution. Turns out that we use the inner join here. And as you know, the inner join will remove the rows from the left side, from the employee sides that don't have an employee on the right side. So the employees that don't have a manager are removed. Let's have a look here again at the employee table. Ben Smith does not have a manager. If we switch here to a left join, we see that Ben Smith is now present in the dataset, but he does not have a manager because he is most probably the CEO of the company. Perfect. That is a self-join. Next up is the anti-join. The anti-join can be used to find things that are present in the left table, but not present in the right table. With this join type, we could, for example, answer the question, what are the departments that have no employees? Let's have a look at our data again. We have 3 departments, and from looking at our data, we already know it's the finance, but we have the department ID 3, and nobody is working in department ID 3. If you imagine we are looking at thousands of rows, it would not be as easy as just looking at the data. So this is where we can use the anti-join to automatically find those. Let's clean this up a little bit. Now we want everything from the department table, and now we need to left join it to the employee table E, and in the end now I'm putting it in more rows. It's just the same. It's if I do it like this or like this, it works the same in SQL. Once you get a hang on how joins work, you would typically start putting them in one row for readability. So we join E.department ID equals to D.department ID. And then we can say D.department. For now, it looks like a normal left join, and it is a normal left join. With this, I cannot answer the question which departments do not have employees attached. And to make it an anti-join, I need to add a where clause. This is like mandatory. So where, and in this case, I will say where E.department ID is null. So now I want only the rows from this resulting set where the department ID is null. And this will give me as a result the finance. So this is the anti-join. Again, just a conceptual join based on syntax that we already know, plus a where clause. To understand more what's happening here, let's maybe add the E.department ID without the where clause. Running this, we see this is a result that we had after a normal left join. And with the where clause, we specify to get only the rows which don't find an joined row on the right side of the join. Putting it here again, only the one with a null remains. That is the anti-join. For now, we have only worked with 2 tables. Now let's add a third one to see how we can join multiple tables, 3 or more, in the same fashion. To do this, we will work with a new set of tables. We will keep the employee table, but we will also have the employee skill table and the skill table. As we have seen the employee table multiple times now, I think it's not needed to go into it again. So let's have a look at what skills we are working with. And there we have a table with 2 columns, skill ID and skill. We have the skills 1 to 4, and the skills being SQL, Python, Excel, project management. And then we have a table that is linking the employee to a skill, our employee skill table. And here we have an employee ID, the skill ID that an employee is obtaining, and the level of expertise they have. So row number 1 would mean employee number 1 has skill number 1 on level expert. Then let's have a look how we can query it. Goal would be we want a list of our employees and the skills that they obtained. Left join employee skill table, let's call it ES, on ES dot employee ID equals E dot employee ID. Let's have a look how this looks for now. Here we have now our first join, a normal left join, nothing new until here. And we see that employee ID number 1, our Ben Smith, has 2 skills, the first one on expert level and the second one on intermediary level, and so on. Now we need to add our third table here, and we will just put it under here and say we have another left join. So nothing new here, it's just continues as we had it before, just another row. S dot skill ID equals to, now we join to the intermediary table, es dot skill ID. So when I execute this, what will happen is we have this intermediary result set now. So only the first part, we joined the employee to employee skill. And this one becomes then the base. So this intermediary result is the base to which we left join the skill. So let's have a look at the result. And there we see it. We get another set of columns, the skill ID and the skill from the skill table. As you see, it's always adding here to the right the new added tables. So our Ben Smith, the 2 skills that he had on expert and intermediary level are SQL and Python. So technically, whenever you join something in SQL, you always take the left side and join something additional to the right side, one by one. And that's how you do your joins on multiple tables. And we also had an example where we were joining a many-to-many relationship, special type of relationship in SQL. I know this was now quite a lot to take in. If you have problems remembering the syntax of the joins, I have created an SQL cheat sheet, which you can download for free. Link is in the description below. And if you like the video and want to see more content coming up, please consider subscribing to the channel.